Hello, I'm SnipeEye. I'm doing the assembly tutorial for the Uno V2 today. For the assembly, you'll need the controller board, which should look pretty similar if not identical to this. There are a couple different variations out there. The circuit board, and we'll go over some of the specifics in a bit here. Either a rotary encoder or a key switch. And if you're using a key switch, an MX style, a chalk style, or an Alps will work. And two headers, one 6-pin, one 4-pin. Depending on the controller you got, you probably ended up with three 6-pin headers, and you can just chop the two extras off. You also need this tiny little LED, kind of hard to see, I'm just going to point to it. It's a very, very small package, and that's actually the hardest thing to solder, but if it gets messed up, you won't have RGB, but it's not going to brick your Uno. It's still going to work just fine. You just won't have the light. So to assemble, let's note a couple things on the circuit board here. You have on this 6-pin header here, 2 pins that on either side have this white silk screen around them, this white oval. These are your reset pins. So when you're programming, it'll often say, hey, reset your controller now. You just short these 2 pins together. So I like to tap them together with tweezers. You can do it with just a small wire, but just connect those 2 briefly to reset it. Make sure that they're not soldered together. I mean, none of these things should be soldered together. None of these 6-pin headers here. You'll also note that this is the back side here. Okay, so the front side has like this text on it and this silk screen here. The back side has where we're going to put the LED, a small little bit of white silk screen on one side of it. And that lines up with the LED. If you, hopefully you can see it here. The LED has a green stripe along one side. That green stripe lines up with the white stripe on the silk screen. So you will take the green stripe on the LED, line it up with the silk screen, and you'll insert it that way. And it'll actually, we'll be soldering it like this, so the PCB is face down right now. The LED will be face down as well. Final couple notes. The switch orientation is important. Obviously the middle of your switch goes right into the center hole. And then on an MX style switch, these pins go to these pads kind of up here. So you'll see this inserts nicely just like this. And you can see where that's poking through. And it's kind of a weird footprint because of the multiple key switch types it supports. If you're using a rotary encoder, your encoder should have 3 pins on one side. This side has 3 pins. And 2 pins on the other side. The 3-pin side goes into the 3 holes outlined by silk screen on the front. So it goes like that, and then the 2 pins will go into holes up on the other side. If you do it upside down, you might be able to solder it in place, but it won't work at all, really. It would be some very strange behavior if you soldered it that way. So make sure you solder it with the 3 pins going to the 3 holes outlined by silk screen. One more couple notes here, I guess. I was going to say a final note, but I'm sure there will be more. Whether you're using a switch or a rotary encoder, you need to be sure that when you put this together, the pins that poke through this circuit board, so you can see it kind of pokes through by, I don't know, it's probably 3 millimeters, maybe a little bit less, maybe more like 2 on this side of the board. You need to make sure that they don't touch anything on this controller board that lives beneath it. Because if they do touch something when you're soldering that, it could be shorting out components and then it's not going to work. This is less of a problem with switches, especially MX style switches. It's more of a problem with some Alps have longer leads, and a lot of the rotary encoders have pretty long leads. So once you solder it through, you're going to want to be sure to chop off any extra length of the lead. Alternatively, there is, when we put the LED in, if we put it in there, you'll note that this rotary encoder sits flush to the board and it covers up the LED completely. Like there's nowhere for it to shine through. So something I actually like to do is I push the circuit board down to the ground with the encoder in there. And then that leaves a little bit of a gap between the circuit board and the encoder for the LED to shine through. And it also has the kind of side effect that none of the pins stick very far through the circuit board. And so they're very, very unlikely to short against anything on the controller board. So for this one, I will be soldering the rotary encoder. If it's the switch, just substitute the switch in, depending on how you're doing it. And we'll go ahead and get started here. The very first thing to solder is the LED, because once we start soldering other stuff, it's going to be very difficult to access the LED. So again, we'll flip it to the side where there's no text, so you have text here. We want the side where the LED footprint has a little bit of white silk screen. And once you've found that and lined it up with the green bar on the back of your LED, you just insert the LED into that small hole there and kind of press it down to make sure that it's seated nicely. And I should be doing this with tweezers, but they're in the other room, so I'm just going to kind of tap it. So you'll see that we have that in nicely. I've got a flux pen here. I highly recommend using just a little bit of flux for this. Flux is just kind of a chemical that helps the solder to wick specifically to metal, so it helps the soldering go a lot easier. And I've actually pulled the LED out with the flux pen, so I am going to grab my tweezers and continue with those. Okay, I've got my tweezers now, and it's a lot easier to deal with the LED with tweezers. So we want the green bar. It's on the left side of the LED here to line up with the white bar in the silk screen. The flux is kind of sticky, so it tends to make stuff kind of drag, but that's in there just how we want it. And I'm going to turn on my iron now. I'm using lead-free solder, and it's very fine pitch, but it really doesn't matter too much what kind of solder you use. My recommended method for attaching this LED is kind of drag soldering, which really means you get enough solder on your iron, and it really doesn't take much, you know, like small amount of surface tension holding it up basically. Like that's probably enough to really get this started at the very least. You kind of hold your component in place and don't knock it out like I just did. And then tap your iron to one of the pins and one of the pads, and the solder, if you fluxed it right, will just kind of flow between them. Yeah, I've got a little bit there. It's probably held in place okay. So I'm actually going to give it just a little bit more flux, because you can't have too much. That's a lie. You can't have too much. Flux can be acidic and can destroy components if you don't wash it off, but it also really makes the soldering process a lot easier. So I tend to use it rather liberally, and then I just wash it off with alcohol. Okay, and you can kind of hear it hissing as I'm touching these pads here now. Get just a little bit more on. And you'll note that the tip I'm using for my soldering iron isn't particularly fine. I mean, it's small. It's not, you know, some giant honking thing. But you don't need a super fine tip. In fact, I find a slightly broader chisel tip is what I use is useful, because it allows you to apply the heat a little bit more quickly. And so let's just get a close-up here on this LED now. Got to find where the camera is. You can see that all of the pins are connected pretty well, and I really didn't end up touching the LED with the soldering iron for that long, which is a good plus, because if you touch it for too long, these LEDs can fry. They're pretty small. They don't have a lot of thermal capacity. So next, I'm going to go ahead and insert my rotary encoder. And I just insert it all the way in, but then I, again, set the circuit board kind of down and press it out a little bit. And then I just kind of eyeball it to make sure that the encoder isn't, you know, really wonky, slanted relative to the circuit board. And this is looking pretty good here. So I'm actually going to bring this soldering iron in as a little bit of a holder for this, because it kind of falls nicely into there. And then the first one I'm going to solder is one of these big pads here, because if I can get one of these big things in place, then I can be sure that the rest of it is not going to move while I'm trying to solder. So that is not the cleanest soldering job I've ever done in my entire life, but it's definitely going to hold that in place. So I'll go ahead and move over to this one. Fill it up, make sure there's plenty of solder holding everything in. Okay. So now we can move on to these 3 pins here and these 2 pins here. And again, just solder the pin in place. This component, this rotary encoder, is a lot less sensitive to heat than the LED, so I can leave the iron on it for longer without any fear of frying it up. That's not nearly as much of a concern. I mean, you probably could fry a rotary encoder with soldering iron heat, but it would look more like melting the plastic of the package than anything else. So, just looking over my joints, I could probably put a little bit more solder into them, but I'm really not concerned about not having a good enough connection. Just looking at it visually, I'm sure that they're making a good connection. So you'll note that I have a little bit of space here for the LED to shine out of. And now we can go ahead and get the controller board installed. So we're only going to use the sides, not the back. I actually like to put the long pins, the long side of the header pins, through the controller board, because this board is a little bit thicker than standard PCBs. So it just makes it a little bit easier to solder, in my opinion. And then we'll line it up on here. So you'll see kind of how that looks. And again, I'm just going to insert it into this as a temporary holder, since it works pretty well for what I'm doing here. And I'm actually not super happy with how it's holding those headers in place. Maybe if I keep my finger on it a little bit. If I can get one of these soldered, then that'll be enough mechanical strength to kind of hold the rest in place while they get soldered. So I'm going to go ahead and heat up pad and the pin. Just liberally give it a bit of solder there. Okay, so now you can see that one's getting held in place pretty well. Let's do the same to one of the pins on this 4-pin side here. Let's see if we can't get that held nicely in place. Okay, that was not a good joint, but it is, mechanically it's there. So I'll just go ahead and solder these individually now. The controller board is also something that you don't want to heat up too much. It's definitely got more thermal capacity than the LED does, but it's still something that I want to be careful with. The rotary encoder is not something I feel even really warrants much caution at all. It's a very hardy component. This controller board is more sensitive, so don't leave the iron on for too long. And if you're feeling like it's getting pretty hot, go ahead and take a break, solder something else for a little bit, and then come back to the controller board. Give it some time to cool down in between. I'm going to redo this joint as well because that one wasn't very pretty. And at this point, you can take some end cutters and trimmers and cut these down. I'm not going to bother doing that in this tutorial because I've already started recording and I don't know where my end trimmers are right now. So we will insert just like that now. And the reason that I, just so you know, the reason I put this on before I started soldering these in place is that sometimes there's a slight mismatch in terms of alignment between this top circuit board and bottom circuit board. So I want to be sure that the header pins are kind of facing the right direction. Sometimes they have to scissor in a little bit. But I've got that going, and now I can just start on these. Again, I'll just get one kind of on each side to give me a little bit of mechanical strength. And then I can go ahead and do the rest without any fear that things are going to come out of alignment or whatever. Okay, all of those ones. And that's all of those ones. So right now, electrically, this is all good to go. Everything's connected. Depending on if you're using a rotary encoder or a switch, you'll put your keycap on or your rotary encoder top on. Since this is not fitting in a keyboard, it's nice that you can use kind of a bigger top if you want, since it's got more space around it. But if you go ahead and plug this into your computer, you can program it. Again, these 2 pins outlined in silkscreen are the reset pins, so just short them together briefly with tweezers or whatever. I mean, it's as simple as that. And that's like pressing a reset button, basically. But this is ready to program. So the hex files for programming and the QMK files for modifying the layout and putting whatever you want into it are coming soon. So I will be able to send out at least an example hex file that you can flash right away just to make sure that your soldering was good. But it's not too difficult all around. Congratulations, you've soldered your Uno V2 and ready to move on.